As we get ready to go into the next portions of our discussion, one of the things that you're probably thinking is, you spent a lot of time talking about RESTful storage. You've been talking about the need for not just new hardware technologies, but not just being storage medium agnostic, but there's this need for RESTful interfaces. Those of you who know a lot about the storage industry, which is most of you, but some of you represent different markets. Some are from high performance computing, others from media and entertainment, others from more of the traditional IT markets, et cetera. You may have different levels of knowledge about this. But one of the things that we want to really make sure is clear is when we talk about REST, which stands for Representational State Transfer, what is it? Why are we using it? REST is the primary set of principles that are used on the web. When communication, whether it's for storage, communication, server-to-server information on the web, typically that's being spoken across a RESTful protocol. Dave is going to go into a little bit more detail about this, but just kind of from a framework, we're talking about the way you from your laptop connect to your social media, the way you access different content on the web, and the way as an organization we can share content across the web. Cloud architectures are RESTful. So public clouds, private clouds, one of the attributes of cloud storage, the idea as a consumer that you can drag and drop content up to an interface provided by whatever company you want to utilize, that's a RESTful storage interface. So Spectra Logic is by no means introducing REST. It's a very traditional, very common storage method of which deep storage historically has not been able to speak that language. You'll hear pieces about this through the day, so I'm not going to go into how we solve this problem, but think about REST as two key pieces. There's clients and there's servers. Clients talk to the server and vice versa, and they have two discrete roles. The clients are the ones who are smart about data awareness. The server is what's smart about the storage. So just kind of thinking about the different roles of the technology. The client software knows about the data, knows about the environment, knows about the workflow. The server of a RESTful interface takes care of the storage details. And then REST architectures are designed to be extremely simple. Nathan was using the terminology get and put. Dave's going to go into more details about this, but from the perspective of block storage being fiendishly complicated and really requiring years of experience to really be able to write software to, file systems being easier, REST, super, super easy. So when I talk about REST and what does this matter to you, all of us use RESTful storage. All of us use RESTful services in some sort of way. So Netflix is based on RESTful storage interfaces. When you as the user decide that you want to watch a film, whatever that film is, you make a request up to the Netflix server environment. A put command goes out to the Netflix cloud that says, Howard would like to view XXX. I'm not sure if that's what you watch, but I like Vin Diesel, so we'll assume you do as well. I might like him for different reasons than you, though. So Howard wants to watch one of the XXX films. There's a put command that goes. We have to have some levity, keep things high energy. I mean the car racer adventure movies, guys. Get your minds out of the gutter, come on. I said we're in proper press conference mode right now, and that this is all free reign. So Howard would like to get his movie out of Netflix. He does a put command. What happens when that request goes to the cloud is a get command then comes back to the Netflix server that delivers that film to a television so Howard can view it. Pretty straightforward. All it really comes down to is he browses to some sort of interface, makes a request, and it's delivered. Behind the scenes is REST. You guys don't need to know that as the user, it doesn't matter. All that matters to you is it's super, super easy to get access to it. Dropbox is another good example that's really familiar to folks. Again, as a user, you get home from vacation, you have a ton of images on your camera that you want to make sure you get access to and store. At the same time, maybe your kids took a bunch of pictures off of their cell phones that were also really great pictures to be able to capture. Historically, without these kinds of RESTful services, you probably lost a bunch of them, you probably never printed them, you probably didn't have a great way to share them, et cetera, et cetera. RESTful products and RESTful services have been built that make it possible for very easily for you all to come in, plug in your devices to whatever system you have at home, put command occurs to pull those images off your camera, put them up into the Dropbox cloud, and then a get command is issued when you want to pull that back down to view it later, to share it with the kids' grandparents, that type of thing. So just real basically, that's how REST works and how you guys use it. All of us use it probably all day, every day in some kind of web service environment. You just don't know it because it's abstracted from you. But that's the technology behind these kinds of storage offerings. So some of the examples of a REST interface. Simple Storage Services, or S3, was introduced by Amazon Web Services. It is what the AWS Cloud Services is built upon. However, it's become something of a standard in the industry, open standard that lots of people are developing lots of different solutions to. Another example is OpenStack. OpenStack is been brought to market in large part by a group called SwiftStack. I'm not going to go into the details of what these technologies are. I just want to frame for you the kinds of products you may have heard about that are RESTful and are RESTful interfaces. The Atmos product from EMC also has its own REST protocol for accessing that storage. And then SNIA, the Storage Networking Industry Association, is working on an open RESTful standard called CDMI, or Cloud Data Management Interface. There are other RESTful interfaces out there and protocols. These are the big ones you've probably heard of. And I just kind of want to bucket them in your minds on similar technologies developed by different companies to solve similar problems. So what is Simple Storage Service? I want to go into S3 in a little bit more detail. It was created by Amazon. They designed it to really simplify web scale storage and computing development. They wanted to make it really easy for developers to access server technology, vice versa, be able to access storage technology, make the web easy to talk to different aspects of the web. It is what defines their cloud storage web interface, and there's cloud storage services from Amazon Web Services. It is also what defines a whole bunch of other services. If you go out to a wiki on S3, you'll see lots and lots of competitive products that are built to Amazon Web Services based on S3. This truly has become the standard and is the market share leader as far as RESTful interface adoption. It's proven technology. There's over 2 trillion objects being managed by S3 services today. It's an enormous amount, and the growth is, a proper exponential curve. And one of the key things that's really interesting about S3 is there's lots of clients out there and lots of client developers out there. So what that means is, when I say client, I'm talking about the software client that knows about data, that talks to a RESTful server, kind of going back to the first part I was talking about. Hundreds and thousands of clients that are built upon S3 APIs. And there's lots and lots of people out there who know how to write to this kind of interface. So when we talk about one of the biggest obstacles to tape historically, especially for the last 5 or 10 years, has been the interfaces to the storage haven't been evolving as fast as the use cases of the disruptive users in the world. So lots of people know how to write to these kinds of interfaces. Again, looking at what kind of clients are out there that might be familiar to you. Lots of photo stuff on the web. Zamanda, the open source backup product, is also leverages S3. So this isn't all just about picture storage. It goes much, much deeper. Hadoop uses S3. That's how Hadoop communicates as well with its storage. So the use cases are broad, they're consumer-based, they're deep as far as going into the enterprise, and they're also in the emerging markets such as big data. So what Spectra Logic is introducing as the new interface to deep storage, and specifically the new interface to tape storage, is a new interface to tape libraries. We're building it on S3. So again, open standard in the industry that has lots of use cases, very easy for people to implement. However, what S3 needed added to it to work for deep storage is a couple of things. One, sequential media support. S3 is not designed to work with sequential media, i.e. tape, or other kind of more linear recording media. S3 is designed to work with random access media. So when you look at why is tape not currently in a lot of cloud services? Why don't you hear tape related to object storage? primary reason is the market share leader, S3, with their RESTful interfaces as well as the others, don't know how to take advantage of this media type. So we are introducing two things to the S3 protocol. We're adding in sequential media support, and we're adding in removable media support. Now you can take advantage of the deep storage tier, the cost, the economics, the power efficiencies, and the densities, as well as the capability, if you want to have an offsite copy for the number of reasons that people do, you can support that across a RESTful interface called DS3. What DS3 stands for is Deep Simple Storage Services. So taking the standard, great, broadly adopted S3 and now supporting deep storage.
I came to Spectra about 2 years ago, and one of the first things I did, I was pretty much John and I, and we were looking at things, and one of the first things I did was look at the cost of tape and where tape was and its growth rate, and it didn't make sense to me because the world was exploding with data, but tape didn't seem to be capturing a lot of that data set, and I wondered why. And I started looking at where data was. And it's not in all the historical places we've seen it in the past. It's not backup data. It isn't just normal data that people are using. And John brought up some of those, like media entertainment and genetics and all types of new industries generating all types of data. But when I looked at those spaces, there was a tape win here and there where people wanted to do the integration and they had enough data. But there wasn't widespread adoption of technology, of tape technology in that space. And so I was like, wow, that's a hard problem. And how do we solve that problem? How do we build that thing in the middle that John described? And so I've been in the industry like 30-something years and been around. So how do you solve a really hard problem? Well, you hire somebody smarter than you, and I did, who's Josh Carter. I don't know where Josh is, but Josh is in the room. And Josh was working at Spectra, and he knew a lot about technologies that I didn't, web services technologies. And he was talking about new developers and what new developers are doing, and people coming out of college, what do they know? How do they know to write to things? And what it comes down to is there's a generation of people that don't know SCSI and fiber channel and all these low block points. And we need to provide them, as an industry, a new interface that they can write to, that they can create apps to, that will be simple for them. So what is DS3? It is a defined web service. There are hundreds of web services out there. You know, if you go and say, I want to see a seismic reading from Japan because I heard there was an earthquake there, there is a website that's providing a REST web service back that gives you that data. So this is very well-known technology, and there's thousands of people participating in this. And it uses standard HTTP protocols. Nathan mentioned that, and Molly's mentioned RESTful. I always like when I have slides where I go, oh, Molly mentioned that twice, John mentioned that once. But the one I really want to talk about is inherently WAN capable or compatible. So in storage, we've done a lot to try to keep storage off-site and DR and let's do fiber channel extensions and all this. This is a web service. You could put this box, this interface, into a central site of a corporation who has their web servers for their corporation there. And anybody who has access to that site through, say, an ISP or through private lines that they're leasing will all of a sudden be able to move data to that deep storage device and pull it back. So all of a sudden, everything in your infrastructure that people are building out in these companies works with this interface. So it's a really important point. And let me tell you some things that work. All your firewalls work. So if you have security and you have web firewalls because you have specific websites that only your corporation can get to, private websites that you do not want to expose to the outside world, all of a sudden all that works, the same security works for this. You can put the same security in front of your deep storage system. How about, here's one that's very interesting, web caching. So if you're going to pull an object out of the deep storage system and you have web caches sitting in front and they cache that object up and the next person comes down and says, I want that object, it will come out of the cache, not the back-end storage system, because it knows that object hasn't changed. So the important point I really want to leave you with on this slide is all your web services work just like they do currently. This is another web service we're offering. This is the most popular, and as Molly mentioned, we modeled it after S3. So Josh looked at different interfaces on the web, and he said S3 is a really good one to model because it defines a cloud web storage service. And this is really important because we didn't have to go define all this stuff. And I'm going to show you a list of things that S3 provides us that we didn't have to go out. And why that's really important is on the client development side, because anybody who has provided a client for S3 can all of a sudden now, with a few alterations, provide a client for deep storage. So really important point. She mentioned 2 trillion objects. The announcement was that they started, I believe, S3 in 2005. They grew to 1 trillion in 2012, and then they announced 2 trillion 14 months later. 2 trillion objects represents 250 objects per person on the planet. What the heck are we storing? But there's a ton of data out there. I don't know if any of you analyzed the S3 market or the AWS market. The rumors are that they may cross $1 billion of revenue this year in just S3 services. And if it's not this year, it'll be next year. We talked about many client and client developers. So what is it we like, and I'll say not like, we love about S3? It already has a security model. And what that security model says is I can set up security that says I can drop something into the deep archive and only I can ever get to it. Or I can drop something in deep archive and it's broadly available to anybody who can get to that deep storage system. So they've already defined for us how permissions are done, how access to objects are done through the interface. The next one is data integrity. We really like this being a storage company, is everything that goes across the wire on S3 has a hash code associated with it, such that you can guarantee if it came from Chicago to New York or Chicago to LA, we can guarantee we receive that data correctly. This is really important for a deep storage system because Nathan mentioned, the ability to keep data for a long time accurate. Well, if you don't get the first copy right, it's never going to be right after that. So really important. Another thing is encryption support. With S3, there's a field that says, please encrypt this data for me. And on our side, we can encrypt it. So another one that's very, very important to us is partial data object restore. In the M&E market, this one's really important because they'll typically take a show or a movie and they'll go create one file, and it's a huge file, and they'll send it out to the deep storage system. And then they'll come back 3 months later and say, we want this 40-second bit of that file back because we want to pull some highlight from a baseball game out. And with partial data object restore, which S3 supports, you can say, give me an object, but only give me from this point to this point of that object. You can also associate metadata per object. Molly talked a little bit about this, but for every data object you send down, the user can associate metadata with that object. And then other users can access just the metadata and determine if those are of objects of interest. Infinite scale out. Amazon's at 2 trillion objects. I hope someday we're at 2 trillion objects. So there has been no limit to what we've seen so far with the interface. So I want to introduce a couple, and if you go to the AWS S3 site, there will be the specification for the commands you can send, what's in the commands, and they really fit into 2 classes, objects and bucket commands. So objects are data objects. A data object, we've had some confusion around this, but it can be anything. It can be a file, it could be a medical image, it could be any hunk of data that represents something. And when we say that there's 2 trillion objects in Amazon, there's 2 trillion hunks of data in the repository. Now, Nathan and Molly hinted at what are the operations you can do in objects. If you're on the client side, you can put an object into the repository or you can get an object out of the repository. It's that simple. And why we're talking about why this isn't a tape announcement is because DS3 doesn't deal with tape. It deals with objects. There's nothing on the front end that really talks about tape in the DS3 spec. It says, you send us objects, we'll put them away for you. You want to get those objects back, we'll go get them for you. And we'll talk more about that as we go through today. Objects are very commonly from a file system, and that was kind of hinted at. When you put objects from a file system into S3, you retain the hierarchical nature so that when you restore them, you can put them back into their directory trees. And S3 does that for you. Small objects are supported. You can do objects of 10 megabytes. You can do objects of a terabyte, or I think the spec says up to 1.5 terabyte object size. So an object is a hunk of data. A bucket is a collection of objects. So essentially you take and say, I create a bucket, and that bucket has certain access to it, and it's a large number of objects. So it's not every user in your site would have a separate bucket. It would be your whole site would have a bucket. The only reason you have another bucket is because maybe you have a security domain that you don't want anybody except a selected group of people to get into. So you set up a bucket, and then you drop these objects into the bucket. Should have a graphic on that I'm engineering, so we don't have that. So what I want to talk about lastly is, what did we add to S3 to make it work for us? So what we added was 2 commands, and there's a few more commands in there, so I'm just going to hit the highlights. We added 2 commands for dealing with sequential media, like tape. And I'll say like tape because the spec doesn't deal with it. It could be any sequential media, or it could be random access media too. So what we have to do in sequential media is we have to know a little bit about the future. So as an example is, if you want to deep archive 100,000 objects, 100,000 files at one time, we'd like to know about those 100,000 files before you start the process. And the reason is because we have to allocate space on tapes, how many tape drives are we going to use to archive those. So the bulk put command basically allows us to get the future view of what you're going to do up front, and that way we can plan for it. The way the command works is, I'm going to put 100,000 objects out, and now I'm going to do puts for every one of those objects, and we've now primed our system to collect those objects, put them on tape, and get is just the opposite. You want to get 100,000 objects, we're going to tell you what order we're going to return those in, because they're in a certain order on tape, and the client handles all that. So this is not stuff you would see. You would simply say, move 10,000 objects, get 10,000 objects, and we deal with all that underneath the covers for you in the client side. And we'll talk about that when we get to the client. The last piece that we really added was exporting. So there's no concept in S3 about exported media, removable media. So basically, you can export on a bucket basis. So I told you that objects go into buckets, tapes get assigned to buckets. So as objects come into buckets, we assign tapes to them. And at some point in the process, if you say export that bucket, all the tapes associated with that bucket get ejected from the tape library. So the key points I want to leave you with is the interface is not tape agnostic, or is agnostic to tape, in the sense that there are other storage mediums that you could put behind the DS3 interface. Any removable sequential media is supported, along with random access. The spec will eventually be an open standard that we expect other people to adhere to. We expect a lot of clients to be developed, and we'll be talking about that. So with that, I will give it back to Molly.